Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about a case study of PostgreSQL. We will know what are the user interfaces that is applied by this SQL system and what are the SQL variations and extensions on the types, the rules, the index, the extensibility on the types, and then the storage structure on this PostgreSQL, the transaction management on which the isolation levels differ from the SQL, and finally we will talk about the storage on this indexing. That means the how PostgreSQL handles with the OLAP features. So this we'll discuss today in this PostgreSQL study. PostgreSQL is a version or an open source software for managing the database queries in a structured query language. It has all the features of SQL 2003 and it now believes that the PostgreSQL term comes from the persistent resistance on the reliable system with the GRD system or the in-GRD solution systems. Also, the professors Tim Barkon from this Berkeley Institute constitute with this PostgreSQL, which give us an open source license for handling the structured query language. Now, there are some unique features of PostgreSQL which is different from the SQL, but mainly the SQL queries can be performed with some of the variations and extensions. So first, knowing the user interface, we will go to the SQL, that how we can vary in this PostgreSQL. So the first unique features of this PostgreSQL is it gives us an unique and interactive terminal interface. That at the terminal we can use some PostgreSQL features to that we can use by the user-oriented feature which can apply to this terminal on this end. Now some of the features are we can use the PSQL variables as an extension of this variable that we can use in SQL. Also the annotation that makes this PSQL variables the anyone like this int, float, char or the C++ language support, that is obviously a good feature of in PostgreSQL where it is an embedded one and we can find these characters as in PSQL features. Now we can interpolate the SQL variables within this PSQL variables by giving a colon in front of this name. So the interpolation, this colon int, now it becomes an PSQL variable. Other than that, if we can give say int I, now my I becomes an PSQL variable. Now the PSQL libraries support for the command line interpretation so that we can have execute each of this query not at the file or compiling it, but directly command line we will give input to it and get the result on that command line output. So these are the command line input or the CLI facilities are some terminal features of this PostgreSQL. Now the graphical user interface also used by this PostgreSQL, which uses the gist and gene-like features, which is the generalized structured tree or the gene-like the generalized incremented tree, where we can implement the all features of PostgreSQL and also the SQL. Now first we will talk about the PostgreSQL or PSQL system types. The first type of system is in base system. So the base system give us the idea that is used for not the design purpose, not the implementation purpose. That means now it will be directly implemented in the PostgreSQL. Other than that, design purpose we can use these base systems. That for building the complex data types we can use these base systems. So inside the base systems we have, say for we are introducing 5 base system, that means 5 times we are having the variables and the set of operations encapsulated together inside these base systems, which we can implement to design other base systems and also the complex systems. Now such an example of these base systems are int4 and complex. The complex has got the other base systems to be combined to build in these complex systems. So in arrays like vlength, we can have the variable length array in this complex system. The next type of system is a composite system. Now the composite systems goes for the table of rows. That means now it is selecting the tuples on which it is built on attributes. We do not need to mention the attributes explicitly if it is a composite system. So composite system belongs to the set of tuples that contain all the tuples of a relation. The next one is the domain. Now domain D stands for that an attribute and which value must be satisfied by the attribute. This can be an base system and complex system and also a composite system, but the attribute must satisfy those values. Say for example, if we have the city attribute and we have the city names like Kolkata, Mumbai and Delhi. So if this is the domain of city, then the city name must belong to any of them. So we can either define an base system or an enumerated type out of this domain. So the next type is the composite one, which is an out of domain, that is an enumerated type. Now the domain and enumerated types are mostly same, but the enumerated type has one difference to it, that it is a fixed length list. So now my list become of fixed length. Other than that, it is same like a domain, that it is a length of fixed list where we can have the attribute values and we can say that the array has only this access to the values. Now it is more like the domain goes for an attribute, but the enumerated list goes for an array. Next are the pseudotypes. Now pseudotypes is an important feature of an PostgreSQL where it can use a normal element or the variable data type and then can pseudo it that it behaves like a variable but is actually not storing any memory area for this type of pseudotypes. So there are many types of pseudotypes that we can introduce now. So basically there are some keywords that we can see that used in normally PostgreSQL, not any others, like the void we use in C++ language to signify that it is a pseudo data type. So it is actually not the type of data, but it is actually identifying something or some variables in such a case. So void means that the function will be void. Trigger means that we are creating a trigger now. Record for creating a record. Anything means any variable it can be. Any array means any type of array it can be. So these are the type of pseudotypes which is an most unique features of PostgreSQL. Next is a polymorphic type. The polymorphic type is a collection of four things: one any array, any non-array, any enumerate that we can have in this polymorphic type. Now the functions that uses this polymorphic type variable are known as polymorphic function, where we cannot use this type of data as the argument of this function but can have as a return type of these functions. So particularly this four collection is known as a polymorphic type. See, we have created the polymorphic type P, so we can have P function F1. That means the function is having the return type P of this function name F1, but we cannot have this P as an argument of this function. Now we will talk about rules. Now to create rules, we may use some of the SQL variations on which we are based on this PostgreSQL rule. So like the check constants that we have used in the SQL, we can use it in the PostgreSQL too. And also like the check constraints, we can use the insert, update, delete, all these statements. Now how to create a rule? Let us first look at this example. So this is the basic syntax for creating a rule. We can see that command create rules, then finally the name of the rule. As on, we can perform any of the select, insert, update or delete or any combination of them. Now to the table name where we need to put the rule clarification and use do instead. Now the term do instead tells us that how to perform and query where the qual on this qualification exists. Now nothing means if the qualification doesn't satisfy, then what we need to perform. So the rules, unlike the procedures and the triggers inside an SQL, it do not use the pre-requirement of this query. So it is a query rewrite rule. So how can we perform this? First it parses the tree and then generates an optimal tree from this query. And from the top-down approach, it just executes the query, unlike the procedures and triggers which execute it in the bottom-up fashion. So the rules can be implemented by views, while views can be implemented by tables. So first, to create a rule, we need to implement it as a view. Say here my tab is the table name and v1 is the view that we are creating. So we are using create view v1 as select star from my tab. So this select star from my tab is an inner query, and as a result we are creating the view on this tab. Now in PostgreSQL, to access the view, we need to create again a table on that view. That means we need to create table v1 now. As v1 is a view, so only the table will be created on a view, no new table will be created. That is why we have used the column list same as the my tab. Now see what we are using. We are creating the rule return as on select to v1. That means as on we are selecting v1 to create the rule return based on some rule qualification. So we can either use the select, insert, update or delete. Here we are using the term select. So either we are selecting the view from v1, otherwise we can select from my tab. So both of this is same for the rule creating return. Here we are not introduced any rule qualification. We will see that in another examples. Here what we are seeing that we can either create a view and use that view, or either can create a table and directly create the table from this rule. Say suppose that I want to query on a salary increase of every possible employee that belongs to an organization. Now what we can do, we can bring a rule in this consideration and put the rule in every such employee relation where we can fetch the salary increase. In this rule, as we want to log all the salary increase, that means first we need to increase the salary of the instructor and then we need to log it. So that is why we have used update to instead of select to. So this is the condition for selecting the update, that if the new salary is not equals to the old salary, where the new and old will be some aliases. Now inside the do instead, we are using do insert into, because we are inserting the values into the field or the log records. So now we are having all the current timestamp and current user values that we want to insert into the salary audit, as the salary has been increased to the user as the instructors. So this is the basic query that we are having. So creating a rule cell audit to update the instructor when new salary is not equals to old salary, and then insert the log into the values where we are inserting the timestamp, user, new dot name, old dot salary and new dot salary. So that is we are inserting a log inside this rule. So now whenever we can perform this rule, we will insert every instructor to this log. Now let us go for a more complicated insert. Say for that we want to increase the pending salary on that instructors. That means not only the salary or the previous salary that was not updated. See here we are inserting the approved new salary. So that is why we are using the insert to command, not the select and update to. So as the rule qualification we are using that instead update instructor. That means other than inserting to the approved increase, we can update the instructor table to increase the previous salaries. So here as the rule qualification, we are adding it into the rule, as in the previous times we have not done. So now we are setting the salary to the new increase that is added to the salary. That means the increased amount on the pending salaries, where we need to put some conditions. Based on the condition that the name is the new name, that means the modified salary is this, that is why we are modifying the salary. So from the first we need to have the salary or the instructor names whose salary is pending as the new name, and if these two matches then we are increase the salary and then increase the rule that to insert into approved increase. Now we are inserting into the approved increase that we are selecting from the salary increase. And now we are having this rule predefined to it. Since the instead is used inside this rule, so the table will not be unchanged, because this approved insert on this approved increase table is already being presented in the rule. So when we need to not change the table, then we can put this instead command in this rule. Now inside this update, insert and select, the update is the most complicated and also the more complex one, because we can have most of the operations like selecting or inserting, then updating, then with a condition joined to it. Now we will go through the extensibility to the SQL version so that we can extend it to PostgreSQL. First one is the extension of the types. Now there's some composite type of definition like the table that we can create here, the type. So it is more like a table definition. Create type followed by the type name. So this is the basic structure of creating a type, that we are creating the type city type as the name and state. That means now my city constitute with the name and state. We can also create a type with an enumerated type that we have described in the user interface section, that a type will contain such values. So we can predefine the values with the not domain but a type also. So here we can have the status T as the enumerated alpha, beta and release to it. Now how can we select these names from this status? Say for this example we are having this query. Say here the use of this such types, that what we are doing, that the steps were enumerated as alpha, beta and release. That means it will be numbered as alpha 1, beta 2 and release 3. So now if I have written status is greater than alpha, say a string value can be checked against and greater than and less than comparison, because now my status can be moved from alpha to beta to release. So by checking this status greater than alpha, that we are checking that if its status has been moved past the status T from alpha. So these are some unique features of PostgreSQL which is extended from the SQL. Now also that the PostgreSQL can use the not null and this unique constraint that we can use in this SQL query. Say suppose that we use the embedded SQL features in PostgreSQL, we have created an type def or a defined structure in C, and we can use this defined structure inside our PostgreSQL. Let us first create an C type def. So in C, we are creating a structure complex with two double types, that is X and Y, and name that complex data type as complex. Now we can directly use this complex inside this PostgreSQL. See, now inside this PostgreSQL, we have created the type complex with this interlen input, output and element as in 16, complex in, complex out, and this double. So now this double or the complex and is same as for use. Next is the use of function that we will introduce inside an PostgreSQL. Now we are creating a function using the create function statement, where the function name is complex out and it uses the type complex that we have defined previously. Now the returns is the function property that is different from procedure, that procedure doesn't return and function can return or cannot return. So now we are returning the character string as the shared object file name. So inside the function complex out, that means we are giving an output on a complex data, that is the shared object file name. Now the language we are using here is an C language with an immutable strict notation. Now this is the proper allocation of a function. Now we will define the function. So the Fiji function info v1 is the function info, that is the function that we will have procedure in the PostgreSQL of this complex out. Next is the data for the complex out. It is the PG function args. That means the Postgre function arguments that we are using as the argument to this complex out and returning this shared object file name. So why we are using the PG function args? Because we have used a complex data type here, which is an argument of PostgreSQL type. Now to create a pointer of the complex type, that is the use of t, we are using complex star c equals to, which is a pointer of complex star. Now whenever we need to create a pointer, we need to create with pg getarg pointer function with the 0 arguments for a successful creation. Now a character pointer for storing the result. So the function palloc, it stands for PostgreAlloc. It is just like the malloc and calloc and used by the PostgreSQL function. The snprintf is the printf function for PostgreSQL. Now we are getting the result and this complex x and complex y value that we have defined at the structure of the C variable complex, which has two variables on double size, x and y. Now finally we will return the result as the C string. Now this is the basic use of a function and how the data or the architecture of the function is written in PostgreSQL. Now whether we can create an aggregate function on which we can create an aggregate. Now the aggregate is a special type of function that has predefinition from SQL. Now the PostgreSQL uses this aggregate function as, now we are creating an aggregate function sum where we have the S func, that means the function what we need to perform is the complex addition with the base type as the complex data, the sum type as also the complex, because two complex data the addition will be complex, the S type as complex, and finally the init condition, that means the initial values of x and y to init cont as 0 and 0. So this is the basic structure of a sum aggregate function. Now, other than the function, we can either create the operator on which the complex operation we need to perform. So let us create an operator. So the create operator function can be creates a PostgreSQL operator. Now let us look at this statement, create operator class. That means we are creating an operator class complex operations, which is default for type the complex, and the index that we are using is B3. So in this PostgreSQL we can be supported with B3, B++3 both. We are using here B3 as we will follow with the operations. See what we are doing, we are creating an operator and give the operator a number, that is 1, which will be used to operate this less than between two complex variables, less than equals to for 2 using two complex variables. So first the keyword operator, then the number, then the following operator with the data types. So in this way we can give all the operator list. See inside the operator we can even use the function also. So by this we can use an operator with the class operator, type complex, index B3 with this operator and the function name. See this operator 1 and function 1 is different from each other because they do belongs to the operator and function class. Now finally we will discuss about the DDL concurrency control on the MVCC application, where we can have different types of DDLs and for which we have the PostgreSQL syntaxes. So the first lock that we are having is an access shared lock. By the access shared mode, the lock on a data item, the concurrency said that it will conflicts with an access exclusive lock. And obviously it is required by the select star from statement, because in the selection we need to have the shared mode lock, and now we cannot acquire any of this exclusive mode lock on it. The next one is a row share. With the row share we can share each tuple individually. So it is on a tuple that we are locking, and this conflicts with then both exclusive and this access exclusive for the update sincere. Now if the row share is there, then it will conflicts with an exclusive if we are for the update statement, and it will conflicts with an access exclusive statement when it is select for the share. Next is a row exclusive statement. We can acquire a row exclusive lock when we want to perform the update, modification or deletion of a tuple. Now it conflicts with all the both, because the share row exclusive, access exclusive and exclusive. This go with this access exclusive, exclusive, and again the share and row share, because it is acquired for the update, delete and insert. Next is a shared lock. The shared lock goes for the entire DBMS. That means when we want to create an index, we need a shared lock, and it conflicts with all the locks. Next is an access exclusive. One way on to access exclusive and particular relation, that is the database that we want to drop table, that we delete the table, delete the tuples from table, and this one. See, it does not conflict with this access share, because in access share we can see and read the database, while we can create the database using the access exclusive. So all these one are the lock that has conflicts with this acquired statements. Now if we can tell that the transaction management or the isolation levels that is attached with this MVCC on the PostgreSQL. So we can create a compatibility matrix on this isolation levels of PostgreSQL. So if it is a read uncommitted, then there can be a problem of dirty read, because we are committed on this read and not being the transaction be successful. That means the read uncommitted is dirty read compatible in a maybe sense. That means it is not confirmed that it will go for our dirty read, but it may lead to a dirty read. But if it is a read commit, that we have committed the transaction with the read or the repeatable read and also the serialize, then we cannot have the dirty read. Now for the non-repeatable read, both the read uncommit and commit can non-repeatable read. That means it will read a value and then to go another transaction to read that value, not repeatedly read the value. But for the repeatable read and serializable, we cannot have any non-repeatable read. Now with the phantom read. So what is a phantom problem? That one insertion is been there while other transaction is updating the value. So we are reading an phantom value that has not been inserted till now on this update. So for the serializable, we cannot have any phantom read because the transactions are serialized. So one transactions will have all of its operation grouped together. So for the serialization, we will have no phantom read, but for both read commit, read uncommit, and repeatable read, we can have the phantom read. So this is the isolation levels that is associated with the PostgreSQL. So that are the features that we have as an extension for the SQL to the PostgreSQL. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.